Hello everyone, we are Team Dev Dynamos 17, winners of Smart India Hackathon 2023 for the problem statements change detection due to human activities. We thank the Government of India and the ISRO for recognizing our innovative approach and declaring us as the winners. So in this video, we will be giving a complete demonstration of our project and the prototype. So our problem statement was to create a automated system for detecting changes due to human-made objects such as vehicles, buildings, roads and aircrafts, and we had to detect the changes in the water bodies and vegetation over a period of time. So for this we use the technique called as instant segmentation, and by utilizing the YOLO V8 medium-sized model we created our final model that was able to detect all these human-made objects. To train our model, we took satellite imagery from the Google Earth Engine API. We took the images, we annotated them using the software RoboFlow, and then we assigned labels to each human objects. For example, buildings were denoted by 0, grounds were denoted by 1, roads by 2, vehicles by 3, water bodies were denoted by 4, aircrafts using the label 5, and vegetation was denoted using the label 6. Here are some of the samples of the changes detected by our model. For this, we consider the satellite imagery of the same spot but at different time periods. So if we look at the example set 1, in the image 1 at the left side, some of the aircrafts are present, but in image 2, those aircrafts are missing. Our model has clearly detected the changes in the aircrafts with absolute precision. If we look at the example set 2, our model has detected the changes in the buildings. And then our model is also capable of detecting the changes in the number of vehicles as well. Here is the code explanation of our model. For the training purpose, we took images from the Google Earth Engine API and annotated them using the RoboFlow software. These images were sent into the model for training purpose, and after the training was completed, we took the weights of training and kept it under the best.pt file. This best.pt file will contain the weights that will be used for real-time change detection of new images. For this, we created a Python Flask server that will accept images at runtime and predict the changes in them. So we have created two Flask servers. The first Flask server will be used to detect all the objects in the image, and the second Flask server will be used to detect the changes in between two images taken at the same spot but at different time periods. So let me explain you about the first Flask server. So I'll run python app.py now. The website will be running at port 8080. So I'll go to the browser and open localhost 8080. So as you can see, I can upload two images here. So I'll be uploading the image of a particular region taken at two different time periods. So I'll upload one. And this image will be sent to the ML model for getting predicted. Once I click on prediction, the request goes to the post API in this server. As you can see in the console, the results of the prediction are getting printed. So yeah, here are the results of the prediction. So the model took around 9 milliseconds to predict, and the classes predicted here are 4, 0, 1. So as I said earlier, 4 represents water bodies, 0 represents the buildings. If I go back to the website, here you can find it has correctly segmented and labeled all the man-made objects here. For example, the buildings have been labeled with red color and with the label 0, and the water bodies are labeled in green color and with the label 4. So now I'll be uploading the second image of the same spot but at different time period. So now even this image will be sent for prediction, and here in the console the results will be printed. So yeah, because there was no water body in the second image, our model hasn't predicted any water body. All it has predicted is some buildings here. And then if I go back to the PyCharm application. Here we can find the confidence score of our model. It shows 0.94, 0.91, 0.90, and here 0.97. All these represents the accuracy of our model. So on an average, the accuracy of our model is about 95%. So then I'll be explaining about the second Flux server now. Here is the second Flux server, and this will be used to detect the changes between two images. Now I'll be running this server. So this will be running at port number 8081. So yeah, now this will be useful in giving a visual demonstration of the changes between two images. So I'll go to here and upload same images which I had uploaded in the earlier website. So yeah, browse. Now once I click on the detect changes, it will be giving me a image, a heat map we can say, that will detect all the changes between the two images. So as you can find, at the center spot of this image, lake was there before, but after some time it's missing. So our model has successfully detected that, and here at the top part, some of the buildings have changed. Our model has detected that also, and this part is also changed. Our model is successfully detecting that. If I add some new image, let's suppose I'll add of a different region. So this time I'm uploading the image of a airport. So once I click on detect changes, so this is giving me all the aircrafts that have been changed over a period of time. In this region we can find there were four aircrafts, but in this image they have gone missing. So our model has successfully predicted the changes between them. Now let us look into the real world application of our model. For this, we created a Next.js web application that will be communicating with our segmentation model. We also created a mock satellite that will be sending the images of a particular region each and every hour. Those images are stored in the MongoDB database. Our Next.js web application will take these unpredicted images from the database and send into the model for prediction. This process doesn't require any client's presence. This is done using a standalone bash script, and even without the presence of the client, this process will be continuously happening in the backend. So the predicted results are sent into the Next.js application, and those results are updated in the respective MongoDB collections. This architecture can be used for creating complex softwares under various domains. For example, it can be used for continuous security surveillance in the border areas where continuous monitoring of human-made changes are required. It can also be used to predict the urbanization factor by comparing the number of buildings changed, grounds, roads, vehicles of different time periods, we can predict the urbanization factor. It can also be used to detect the environmental changes by comparing the water bodies and vegetation change over a period of time. To end with, I would like to once again thank the ISRO, the GTU, and all the judges and the staff on the behalf of my entire team and my college for making the hackathon a memorable one for us. And thank you once again for declaring us as the winners.